Okay, so students were challenged with a review question here. Sine of 7 theta equals 1/2. Well, first off, we act like there's no 7 there. We just figure out sine of theta is 1/2. To do that, I end up with triangles in the two places where sine is positive, and I end up with pi over 6 as one of my answers, and 5 pi over 6. But since it's actually a question about 7 theta there, then 7 theta is equal to pi over 6, and 7 theta is equal to 5 pi over 6. But there's something missing from both of my answers. Mr. Good, did you catch what I needed to put there? Plus something.
Plus 2 pi k.
There we go. And then John Rafferty, how do we get the thetas to be alone again? I just want theta, not 7 theta.
You divide everything by 7.
True. I'm going to multiply everything by 1/7. And here too. And then this will cancel this, and it's just theta. And that'll cancel that. And the final answer, pi over 7 times, that was a 6, so 7 times 6 is 42, plus 2 pi k over 7. And when would you ever actually get all of the 14 answers? There's 7 times as many as normal. Only if we said find all of the answers between 0 and 2 pi. Then you would actually have to find all 14. We'd never do one that was that big, because frankly, we wouldn't want to have to grade it. So 5 pi over 42 plus 2 pi k over 7. But if I had just wanted to like start that process, if you put in 0, of course, you get this. That's one of your answers. If you put in k as 1, then you'd want to add 2 pi over 7 to 42. So I would get a common denominator by timesing by 6 on the top and bottom. That way it's got a common denominator, and that would mean adding 12 pi to the 1 pi, and I'd get a next answer of 13 pi over 42. And you could just keep going like that ad nauseum until you eventually get a total of 14 answers. 7 or 5 pi over 42, same thing. I would times this by 6 and 6. Okay, so that's one of your big hoo-ha types of problems that we've had. Another big hoo-ha type of problem that you've had is to find the intersection point between two vectors. Let's just talk about that briefly. X, Y, Z, we're not going to actually do the whole thing. They take forever. But I want to make sure you get a few distinctions about vectors. Like, there's only one part of this vector equation that's actually a vector. Charlotte, which part is the actual vector here? Yep, that part's the vector. So if you were going to do dot products, for instance, you only do those on vectors. So if we were going to do a dot product, we'd use this and maybe another vector. What if I had two dot products that equal 0? Do you remember what the deal was with that? Then they're perpendicular if their dot products are 0. All right. How do you do a dot product again? Well, let me give you another vector. Let's say I have another vector and it's 1, 1, 1, 1, 1. That's about as simple as I can make it. Well, then this times this plus this times this plus this times this gives you your dot product. All right. So that'd be 2 times 1 plus 2 times 1 plus negative 3 times 1. And that would be 2 plus 2 minus 3. That would be 4 minus 3, which would be a 1. Does that mean they're perpendicular or anything special? No. The only special dot product would be if it came out to a dot product of 0. Okay, so that's dot products. What's that one formula where you find the angle between two things? I'm going to give it to you. A dot B, this is dot, equals, it says absolute value, but it's actually called something different. Do you remember? Magnitude A, magnitude B, and then cosine of the angle. That's the big hoo-ha formula for that. Do you get a formula sheet? Yeah. Do I promise that every formula you ever want is on there? No. You want to know what's on there? Well, look at it. We've given it to you before. It's in the folder from Tuesday of last week when we started the review. That's where it is. Okay. So let's talk about another thing that I'd want you to know well. Do you remember the sister functions? If I asked for cosecant of some angle equals negative root 3 over 2, could you solve it? Actually, I messed that up. That should be flipped. Sorry, 2 over negative root 3. Well, the first thing I would do is say, I don't want to do cosecant. I want to do sine. If I do that, you never flip the angle, but you do flip the side ratios. So then this has now become this problem, which should look familiar. It's a lot like what we just did, except this time sine is negative, so it can't be here and it can't be there. I like to put the ASTC up there every time. And then I think to myself, where is sine negative? Well, there's only those two spots left. So I guess maybe I should probably get two answers then. Now, this did not say anything about, like, only find the answer between 0 and 2 pi. Now, technically, that means you should give all the answers. So probably slap on a what? Plus 2 pi k. Now, you can ask me on the test, but if it doesn't say anything, then you would probably default to all solutions. You usually say, find all the solutions to kind of remind you that you better add that plus 2 pi k. All right, so sine is opposite over hypotenuse, and this must be the 1. What's across from the 1 is the 30, but that doesn't really matter. What's across from that is a 60, aka pi over 3, but it's not really pi over 3 because that'd be over here. Pi over 3 is 3 pi over 3 plus 1 more is 4 pi over 3, and I don't even have to draw this one to know that it's got to be another one. 5 pi over 3. How did I know it wasn't 6 pi over 3? Because 6 pi over 3 would have been 2 pi. And that would be too far. There we go. 4 pi over 3 and 5 pi over 3. Who had that one right? Okay, cool. That's just to remind you of the sister functions like cosecant and sine are flips of each other. All right. If I had this equation, 3 cosine of 4 x minus 5 plus 6, could you tell me the period of it? If you know a little formula, you could. The amplitude would be too easy. That's just 3. How far up it was shifted? Too easy. That's just 6. But the period, Leanna Miller, do you remember the period formula?
It's 2 pi over b, right?
Excellent. And did I tell you b?
4.
Yep, b is 4. So there you go. Boom. Period is 2 pi over 4. Could you simplify that? Yes, and you should. All right. Next thing I want to talk about is if I had a graph and I asked you to graph 3 tangent of 2 theta. Can you do it? Hopefully you remember what tangent looks like in the first place. Tangent goes like this, and the tangent line itself goes like that, and then these are at pi over 2 and negative pi over 2. but there's a spot along the middle that's kind of important, and that's where it hits 1 and -1. So here's 1, there's -1, and those are halfway in between, so this would be pi over 4 and negative pi over 4. Got a little messy in there, sorry about that, but move that up above it. Okay, now this 3 here just simply changes this 1 to a 3 and the -1 to a -3. And this 2 here goes through and multiplies by 1/2. Why is it doing the opposite of what you'd expect? Because it's on the inside by the x, by the variable. So it's on the inside, does the opposite of what you'd expect. You multiply by 1/2 everywhere. All right, I'm going really fast, but I'm covering a lot of stuff here that's all important. Okay, the next thing is, let's say that I had this problem. Solve. Pause for a second. Give that a shot. All right, Vivian, did you know how to start? I'm going to give you a hint. Always take quadratics, see there's a squared there, and set them equal to 0. Now, if I tell you that, what do you think the first step should be to make the thing equal 0? Wouldn't it be fairly easy to make that side equal 0 if you... Yep, add 1 to both sides. So now you have 2 cosine squared theta plus 3 cosine theta plus 1 equals 0. And now, if you're stuck, I want the first thing that you do to always be, I wonder if there's a chance there could be that thing that he keeps coming back to over and over again, so much that there's a sign on the wall, which is, yeah, you should be able to factor it. And this one, do you think you can factor it? Oh, yes, you can. If you can factor it, you should. How many of you already have it factored? Only a few. I'm going to give you a minute. Do it in 3 stages. The first stage you got to figure out is what goes here and here. That would multiply together and make 2 cosine squared. Who would have thought there'd be factoring on the final? Hey Jack, you got the 2 things that multiply to 2 cosine squared?
Yeah, 2 cosine theta plus 1.
Hold on just a second. Just one thing at a time. 2 cosine, and then this one's cosine.
Yeah.
Next, you just have to think about signs. I made this one super easy in 2 ways. Hopkins, do you know why? Well, I'll give you one of them. There's only plus signs. That makes it super easy. Gotta be plus signs. And the other way it's super easy is how many ways are there to break up a 1? 1. So it's gotta be a 1 and a 1. So I made it as easy as I could make it. All right. Now, just to be sure, you go first, and that makes 2 cosine squared. Outside and inside is where it all the action happens. So this is 2 cosine, and this is 1 cosine, and you put them together, and you get 3 cosine. And there you go. So the cool part about the end of this is that it does factor, which is a thing that keeps coming up over and over in this class, and that it makes you review not just circle trig, but circle twig, twinkle twig with quadrantals. It's got a quadrantal in it. So figure out, especially this one, find that answer. I'm going to even just skip this one because it should be too easy for you. Cosine of theta equals -1/2. And we just did something like that 2 seconds ago. You get 2 answers. This one, however, is a quadrantal. I'm going to pause for a second while you give that a shot.
draw, you do the circle, and then
I agree. I'm gonna take these 4 spots as the important spots, and then what?
cosine is at x, so x equals -1 would be all the way on the left of it.
That's the only one where x equals -1. If you need to, just list them all. You know, that's 1 comma 0. This is 0 comma 1. No negatives yet, right? This is -1 comma 0. Oop, that one's the one where cosine, which is x, is -1. And so what angle is that over there? That is pi. The point of this is try to figure out the angle, right? And we figured out the angle, and it was pi. There was 2 answers for this one. I'll just do it super fast. Cosine's negative, so it can't be here and it can't be here. And I draw the triangle. And cosine's adjacent over hypotenuse. 1, -1, and a 2, and that makes this a square root of 3. And what's across from the square root of 3? Ooh, that's a 60. But I don't say 60, I say pi over 3. And it's not really pi over 3, it's 2 pi over 3. And the other one would be 4 pi over 3, because it'd be down here. So there's my 3 answers. 2 pi over 3, 4 pi over 3, and pi. Okay. So I did not just cover everything at all, but I covered a bunch that I know will be helpful. If I was going to just leave you with one parting thought, if you have an x, y, and a t, what kind of equation do you have? Yes, this is a parametric. Can you change this kind?
Yeah.
To what? Yes, you can change it to rectangular. All right, so let's say I had 2t here and I had a t squared minus 3t here. If I was going to change this, the number one thing I would do is make a txy chart, because it helps you change this limit here. Because it can't be based on t anymore, because you're going to get the t out of it. So make a txy, everybody. And then also, can you solve this and then stick it into this to convert this to rectangular? I'll give you just a minute. If you don't know what's going on, you'll see me do it. Okay, so to finish this off, I'd first make the txy. If I stick in 0 for t, I get 0 here, and 0 here, and 0 here. I get 0 and 0. Okay. Next, if I stick in a 1 goes here, and here, and here, and I get 2 times 1 is 2. And then 1 squared minus 3 times 1 is basically 1 minus 3, which would be -2. And last but not least, I put in 2. And then this becomes 4. And the other one becomes 2 squared is 4 minus 3 times 2. 4 minus 6 is -2 again, I think. Anybody verify that? Okay, good. And it can happen because it's a quadratic, and so it's got a curve in it. And so if you actually graphed it, it would make more sense. Now, the limit used to be between 0 and 2. Can I just say, oh, we're going to use x for my limit. So x is between 0 and 2. No, can't do that. Because x is not equal to t. But if I solve this thing now for t, t would equal x over 2. And that means wherever I see t down here, those t's, I can put in x over 2. So then my answer would be y equals x over 2 squared minus 3 times x over 2. And there's my equation that has only x and y's in it. But then it'd be a fatal flaw to leave it that way because this had a limit. So now my limit can be based on x or y. I would be fine with you just picking the x limit here. But I can't just say that it's between 0 and 2 like it was in the first place. But the x's are now between 0 and 4. That's the especially good thing about having the txy is you can refer to it at that moment. Say x has to be between 0 and 4. Okay. That's a good review. That's not everything, that's a bunch of things that you'll wanna know. And you can ask individual questions, one right now, yes? Yes, so this is the part where I'm gonna allow you to come up and ask me individual questions, and that's all I have for you for today.